Welcome to the series of lectures on control systems. Myself, Dr. M. Kiran Kumar, working as an associate professor in the Department of EEE, Koner Lakshmi Education Foundation. Today, we are going to discuss about the transfer function and finding the transfer function for open loop system, closed loop system, electrical system, mechanical system, and for a differential equation. Let me start with the transfer function. If you look at the definition of the transfer function, it is the ratio of Laplace transform of output to the Laplace transform of input under the initial conditions are equal to 0. Then let us see the transfer function for open loop system. The open loop system is represented as a system is G of S, and the input to the system is, let us say, R of S, and the output is C of S. Now, as per the definition of the transfer function, it is the ratio of Laplace transform of output, that is C of S, by Laplace transform of input R of S is equal to the value G of S. Now here, if you look at the importance of the transfer function, the transfer function is going to give you the mathematical modeling of the system, that is C of S by R of S is equal to the system. Here for a open loop system, the system is represented as G of S. Let us see the transfer function for a closed loop system. A closed loop system, we all know it is having a feedback. So initially the system is G of S, you have the input R of S, and the output is C of S, and we have a feedback. Let us say that feedback element is H of S, and that is connected to the input. And here for the explanation purpose, I am considering a negative feedback system. Now if the system is like this, then how to find the transfer function, that is a Laplace transform of output C of S and the Laplace transform of input R of S is equal to how much? Let me start explaining this from assuming the error E of S. Here, if you observe, the value at this is equal to H of S into C of S. The reason is the C of S and H of S both are connected in cascade connection. So if those two elements are in cascade connection, the resultant will be your H of S into C of S. Now if you look at the value of E of S, the error E of S is equal to the difference between the input and this value, that is H of S into C of S. That is the difference between R of S and H of S and H of S into C of S. Now similarly, if you look at the value at this location, it should be equal to, that is the value is C of S and it is equal to your E of S into G of S. Here also the same logic, E of S, G of S both are in cascade connection. Now with the help of these two equations, we can find out the transfer function for the closed loop system. From this equation I may write the E of s is equal to C of s by G of s. Now using these two equations, that is E of s is equal to, from the previous slide, C of s by R of s, C of s by R of s, and the another equation which is error, that is E of s is equal to H of s in R of s minus H of s into C of s, that is E of s is equal to R of s minus C of s into H of s. Now if I substitute the E of s value, it becomes C of s by R of s, C of s by G of s. This is C of s by G of s, C of s by G of s is equal to R of s minus C of s into H of s, and then C of s is equal to R of s into G of s minus G of s into C of s into H of s. Now if I bring this term into left hand side, the C of s plus G of s into C of s into H of s is equal to R of s into G of s. So if I take C of s common, it becomes 1 plus G of s into H of s is equal to R of s into G of s. Now what is transfer function? Transfer function is Laplace transform of output, that is E of s, and the Laplace transform of input, that is R of s, which is equal to, we have G of s by 1 plus G of s into H of s. Now this is what the transfer function of a closed loop system. Now so far we have seen the transfer function of a open loop system, that is C of s by R of s is equal to G of s. This is for open loop control system, and similarly C of s by R of s is equal to G of s by 1 plus G of s into H of s. This is for closed loop control system. Now the difference what you need to observe is, from the closed loop system, if I consider a negative feedback, now we are getting C of s by R of s is equal to G of s by 1 plus G of s into H of s. If I take a negative feedback system, in the denominator we are getting 1 plus G of s into H of s. Similarly, if I take the positive feedback system, now if I do the same process, I will get, instead of plus, I will get minus. The important note what you need to observe is, in case of negative feedback system, in the denominator you are getting 1 plus. In case of positive feedback system, in the denominator you are getting 1 minus. That is the very important note. Next, let us see the transfer function for a given electrical circuit. In this, we will see how to find the transfer function for a electrical circuit. Before I start finding the transfer function for various electrical circuits, let me give you a brief introduction about finding the Laplace transform of a pure resistor, inductor and capacitor. If I take a pure resistor, the value let us say R. Now From the previous classes or from the intermediate level, we know the Laplace transform of resistor becomes a simple R. The Laplace transform is denoted the symbol like this, and if I apply Laplace transform of resistance, the value you are going to get is a resistor only. If I take an inductor and if I apply the Laplace transforms for this pure inductor, the value which I am going to get is L into S. This is the Laplace transform of inductance. Similarly, if I take the capacitor and if I do apply the Laplace transform, what we will get? We will get that is 1 by Cs. So these are the three important notes which we need to remember before we are going to start finding the transfer function for a given electrical circuit. And a few more basics from the Laplace transforms are: Laplace transform of 1 is 1 by S. Laplace transform of t is 1 by s square. Laplace transform of e power minus at is 1 by s plus a. Laplace transform of e power at is 1 by s minus a, and so on. So all these formulas are going to play a vital role while finding the transfer function for a given electrical circuit. Now let me start a simple electrical circuit and finding the transfer function for that electrical circuit. Let me consider a simple RC circuit. Now let us say we are taking the output across the capacitor, that is a V0 of t I can say, and the input is a Vi of t. Now this RC series circuit is also known as a first order circuit. The meaning is, here since there is only one energy storage element, the order of the equation what we are going to get is a first order equation. That is the reason this RC series circuit is also known as a first order circuit. Now one more point here I would like to stress is finding the order of the given system. The order of the given electrical circuit completely depends upon the number of energy storage elements present in that system. If there are two energy storage elements present in that system, then the order must be equal to 2. If there are 3 energy storage elements present in that given electrical circuit, then the order of that system is 3. Now for this example what we have taken, we can see only one energy storage element, that is capacitor. That is the reason this RC series circuit comes under a first order circuit. Now since here we have defined the output, that is V of t across the capacitor, and the input is anyhow Vi of t. What we are finding here, transfer function. What is the transfer function? It is a Laplace transform of output, that is V0 of t, by Laplace transform of input, that is Vi of t. And this Laplace transform of output, V0 of t becomes V0 of s, and Laplace transform of input, Vi of t becomes Vi of s. Now to finding this value, we can use a simple electrical circuit laws, or like series technique, parallel technique, KVL, KCL. We can use any fundamental laws to find out this V0 of s by Vi of s. First, I always suggest, since you are finding the transfer function, you need to replace the given circuit into its equivalent Laplace transform circuit. For that, in previously I have given the Laplace transform of each element, that is resistor and capacitor. The Laplace transform of resistor is anyhow R. See, we are writing the Laplace transform equivalent circuit. And the Laplace transform of capacitance is 1 by Cs. And anyhow I wrote the Laplace transform of output is V naught of S, and the Laplace transform of input is Vi of S. See, since the R and C are in series, I can go with a simple voltage division rule. I need the voltage across capacitor, that is V naught of S by Vi of S, that is same impedance, that is 1 by Cs by 1 by Cs plus R. The voltage division rule says the same impedance divided by sum of the impedances. From that we will get V naught of S by Vi of S is equal to, let me write once again, 1 by Cs by R plus 1 by Cs. Now if I rearrange this, what I will get, 1 by Cs by RCS plus 1 by Cs. From this we will get 1 by 1 plus RCS. See, to say this is the first order equation, we have only S power 1. So it is a practice to make S power S coefficient must be equal to 1. For that we are taking RC common, it becomes S plus 1 by RC. Now it is 1 by RC by S plus 1 by RC. Now this is your V naught of S by Vi of S becomes 1 by RC by S plus 1 by RC. Now the important note that we need to conclude from this is RC. RC is known as a time constant of RC series circuit. So this is time constant, seconds, denoted with tau. So from that we may substitute in this transfer function equation V naught of S by Vi of S is equal to 1 by tau by S plus 1 by tau. So this is the transfer function for the given RC series circuit. That means it is going to give you the mathematical model of that system. See, here we have the output V naught of S and the input Vi of S. Now this becomes a system. Further, what we are going to do is we will analyze the output by taking different types of inputs. We have in time domain analysis, where we will consider the time as the input, and similarly we have one more analysis, that is frequency response analysis. In that we are going to consider the input is frequency. Like that we are going to analyze once if we have a mathematical modeling of that system. The conclusion from this slide is the transfer function is going to give you the mathematical modeling of that system. That is, it is going to give you the value in terms of output and input. Now let me start finding the transfer function of a second order system. As I told you, the order of the system depends on the number of energy storage elements. In the previous case we have seen only one energy storage element, that is a capacitor. Since we have only one energy storage element, it becomes a first order system. Now to make the second order, at least there must be two energy storage elements. The electrical circuit becomes R, L and C. This is very important. Now here we have again the input VA of t and resistor R, inductance L, capacitance C, and the output anyway we are taking across the output capacitance, that is V naught of t. Now what is the best practice I told? We need to replace the given circuit into its equivalent Laplace transform circuit. So for that, a simple Laplace transform of R is R only, and the Laplace transform of inductance is L into S, and the Laplace transform of capacitance is 1 by Cs, and anyhow the input is of Vi of S, and the output we are considering across the capacitor, that is V naught of S. Now again, what is the definition of Laplace transfer function? The transfer function is the Laplace transform of output by Laplace transform of input, and from the above circuit the Laplace transform of output is V naught of S, the Laplace transform of input is Vi of S. Now we need to find out this value, the transfer function. Now as I told you, to find out this V naught of S by Vi of S, we can use the basic rules like series reduction technique, parallel reduction technique, or a combination of series and parallel, and also we have the standard laws like KVL, KCL and so on. Since it is a simple series RLC circuit, let me consider again the voltage division rule. So we want the voltage across capacitor, that is V naught of S, and the total voltage is Vi of S, which is equal to the same impedance, that is 1 by Cs divided by sum of the impedances R plus Ls plus 1 by Cs. That means if I have two resistors connected in series, let us say the resistance R1 and this resistance is R2, and the input is Vi and the output is, let us say, V0. Now since these two resistances are connected in series, and if I want the voltage across R2, that is V0, is equal to, how to write the value? Same impedance or same resistance R2 by sum of the resistances R1 plus R2 into total input or supply voltage. So this is the formula which we are going to use, that is what is known as voltage division rule. Voltage division rule. The same formula if you apply here also, you are going to have V naught of S is equal to 1 by Cs divided by R plus Ls plus 1 by Cs into Vi of S. That Vi of S I brought into the left hand side, so that it becomes V naught of S by Vi of S is equal to 1 by Cs divided by R plus Ls plus 1 by Cs. Now if I rearrange this, what I will get? V naught of S by Vi of S is equal to 1 by Cs divided by RCS plus LCS square plus 1 divided by Cs. Now these two gets cancelled. We have V naught of S by Vi of S is equal to 1 by LC S square plus RC S plus 1. And see, here we have the highest order is S square, that is 2. That is why this is known as a second order system. See, there are two energy storage elements. One is resistor, second one is inductor, and third one is capacitor. Out of these three elements, if you look at, there are two energy storage elements. One is inductor and second one is capacitor. Now always it is a best practice to make highest order coefficient must be equal to 1. So then what is that we are going to get? V naught of S by Vi of S is equal to, what is that we will get? We need to make LC common, so S square plus, here you will get R by L into S plus 1 by LC. Now if I rearrange this, what I will get? V naught of S by Vi of S is equal to 1 by LC divided by S square plus R by L into S plus 1 by LC. Now this is the transfer function of a second order system. This is very important. So this is how we are going to find the transfer function for a different types of electrical circuits. Now as a second case, let me go for finding the transfer function for a differential equation. Now let me consider a differential equation d square y by dt square plus 5 into dy by dt plus 6y is equal to 2 into dx by dt plus 3 into x. Now let us say this is your given a differential equation. In this case, how to find the transfer function? Now as we all know, the transfer function is again nothing but the Laplace transform of output by Laplace transform of input, anyhow under the initial conditions are equal to 0. Now here we will first identify what is the input and what is the output. Now x we will consider as input and y we will consider as output. Now finally what we need? We need the value, that is y of s by x of s is how much? That is nothing but your transfer function. Since the given equation is in a differential form, first let us apply the Laplace transform for that differential equation. So what is that you will get? Laplace transform of d square y by dt square. Since you have a square term, you have s square after applying the Laplace transforms. So s square into y of s plus 5s into y of s plus 6 into y of s is equal to 2 into s into x of s plus 3 into x of s. Now if I take y of s common, what I will get? S square plus 5s plus 6 is equal to, so here we will take x of s common, 2s plus 3. Now the transfer function is the ratio of output, Laplace transform of output, that is y of s by x of s is equal to 2s plus 3 by s square plus 5s plus 6. So this is how we are going to find the transfer function for the given differential equation. Now let us see one more problem also of finding the transfer function. Now let me consider a third order differential equation, d cube y by dt cube plus 6 into d square y by dt square plus 3 into dy by dt plus 2 into y is equal to 10 into dx by dt. So this is the third order differential equation given. Now here we are finding the transfer function. Same procedure. First let us identify the input. The input is x is your input and y is your output. So we need y of s by x of s. So to find y of s by x of s, we need to write down the Laplace transform for this differential equation. So what we will get, for the first term, since it is d cube, you will get s cube into y of s plus 6 into s square into y of s plus 3s into y of s plus 2 into y of s is equal to 10 into s into x of s. I repeat, here since it is a third order differential equation, when you are going to apply the Laplace transform, since it is d cube, so correspondingly you are going to get s cube. Similarly for d square you will have s square. Similarly for dy by dt you have s term. So for y anyhow y of s. So if I take y of s common, s cube plus 6s square plus 3s plus 2 into y of s is equal to 10s into x of s. Now we need the ratio of Laplace transform of output by the Laplace transform of input, that is y of s by x of s is equal to, what you will get, 10s by s cube plus 6s square plus 3s plus 2. So this is the solution for this third order differential equation. Like this we can find the transfer function for various types of systems. Next let us see finding the transfer function for a mechanical system. Again the division under this mechanical systems is, again we have two different types of systems. One is translational system. And second one is a rotational system. In case of translational system, we will consider the input is force, that is F, and the output is distance, that is x. And when it comes to the Laplace transforms, that is becomes f of s and the distance becomes x of s. In case of rotational system, we have again the input, we may consider the torque, that is T of s, and the output we may consider as rotation in terms of Laplace transform, that is theta of s. I repeat, for a translational system, force is the input and the distance is the output. And for a rotational system, T of s is your input and output is nothing but your theta of s. Before I start explaining about finding the transfer function of a translational system, first let us see what are the various elements present in this translational system. Exactly it is similar to the finding the transfer function of a given electrical system. The difference what you need to observe is, here also we are going to have three elements, and those three elements we will denote as, one is mass, second one is a dashpot, and third one is a spring constant. one is a mass element, and second one is a dashpot, and a third one is a spring constant. Mass we will denote with a capital M, and dashpot with B, and spring constant with the value K. Now first let us identify the force in these independent elements. Let me start with from a mass element. The equivalent circuit of this mass is represented as M, and we have a reference, and the force is your input F, and the distance traveled by this body is your X, that is output. And as per the Newton's law, this force is equal to ma. That is the force equation. F is equal to ma, and where we can say in the mass element the force is proportional to a, that is acceleration. From this I may write again F is equal to, by replacing this proportionality constant, again we are going to have m into a, and from the basics the velocity is written as distance by time, and that distance is x, time is t, xt. Small differential element if I take, you will get dx by dt. And if I need the acceleration once again it is d square v, that is d square x by dt square. And this Fm, that is force in the mass element, if I take Fm, it becomes m into d square x by dt square. The reason why I brought the value of a in terms of x is, as we have already identified, the input to this element is f and the output is anyhow x. And to find out the transfer function for this independent mass element, we need to have the Laplace transform of output x of s by the Laplace transform of input f of s. And by using this equation, we, after applying the Laplace transforms, what is that we will get? F m of s is equal to m into s square into x of s. See, since it is a second order equation, we are going to have s square term. Now the transfer function x of s by f of s is written as 1 by m into s square. This is the transfer function for a simple mass element. Now secondly, let me consider a spring constant. In case of a spring constant, if I draw the equivalent circuit, spring, and with the reference, this is your reference, and the value of k is your spring constant, and the distance what we are assuming is x, and the input is force F. Now in case of a spring constant, the applied force is always proportional to the distance traveled, that is x. Now from this I can say F is equal to kx, since we are replacing the proportionality constant with k, And after applying the Laplace transforms, that is f of s becomes your k into x of s. Now the ratio of Laplace transform of output, that is x of s by f of s, becomes your k. So this is the transfer function for a simple spring constant. Let me go to the last element, that is a dash pot. And this dash pot is also known as a frictional element. Frictional element. Now if I draw the equivalent circuit for this dash pot, this is your reference, and this dash pot is represented with B, and anyhow the distance is x and the force is F. And see, the main important point is force and distance both are in the same direction. Now in this, the force is proportional to the velocity, whereas in the case of mass element we said the force is proportional to acceleration, whereas in the case of a simple spring constant the force is proportional to a distance, that is x, and here in case of dash pot the force is proportional to the velocity v. And if I write the velocity in terms of distance, it becomes dx by dt. Now this proportionality constant is replaced with b, that is f is equal to b into dx by dt. Now what is that I will do? I need the value of x of s by f of s. For that what I need to do? I need to go for the Laplace transforms. Applying Laplace transforms on both sides. Or do I get f of s is equal to b into s into x of s. Now from this, x of s by f of s becomes your 1 by bs. Now this is the transfer function for the simple dash pot. That means if a given mechanical system is having only dash pot, then we have the transfer function x of s by f of s is equal to 1 by bs. If you just look at from the starting of this mechanical system, and this mechanical system again it is divided into translational system and rotational system, and in case of translational system the main three elements are mass, dash pot and spring constant, and we have find out the transfer function for the three individual elements. Only for mass if I consider, we will get transfer function is equal to 1 by m into s square, that is x of s by f of s is equal to 1 by m into s square. And if I consider alone a spring constant, then the transfer function x of s by f of s is equal to k. And finally if I consider the third element, that is a dash pot, which is also known as a frictional element, here the transfer function x of s by f of s is represented as 1 by bs. So this is how we are going to evaluate the transfer function in case of the mechanical system having only independent elements like mass, spring constant and dash pot. Now let us see a few examples on a different mechanical systems having a combination of these three, like mass, dash pot and spring constant. Now let me consider an example of having a mechanical system, a mass element and a spring constant. This is reference anyhow, where we are applying input is F, force, and the distance is x, See, you are pushing the system from left to right, and the spring constant is k, and distance traveled by the system is x. Now, how to find the overall transfer function of this system? In case of this mechanical system, we will consider each mass is a node. Here we have only one mass, so we have only one node, that is, if I take m. And what are the applied forces? Applied forces is F. And what are all the opposing forces? Opposing forces, force opposed by the body mass itself and the force opposed by the spring constant K. Now, as per the Newton's laws, we will write F is equal to Fm plus Fk, that is, the applied forces is equal to opposing forces. Now, in previous cases we have seen the values of Fm and Fk individually, that is, F is equal to, Fm is nothing but m into d square x by dt square, plus the force at the spring constant is k into x. So this is the overall force equation. Now here, to find the transfer function means we need to have the value of x of s by f of s, since here the distance is output and force is your input. For that, let me apply the Laplace transform for this equation 1. What is that? You will get f of s is equal to m into s square into x of s plus k into x of s. Now it becomes f of s is equal to m into s square plus k into x of s. So now the output x of s by f of s becomes 1 by m into s square plus k. So this is how we are going to find the transfer function for the given mechanical system having combination of these elements like mass, spring constant, and also the dashpot. Now let me consider one more example of a mechanical system, and that mechanical system is having all the three elements. Let us say all the three elements: mass, spring constant, this is the reference anyhow, and we have the dashpot also, that is B. This is your reference. The input is F, we are applying the force, and the distance what we will consider as the output, that is x. Now in this system also we have only one mass element, that is m, and what are all the applying forces? First we will write the applying forces, that is F. And what are all the opposing forces? So there are three elements. One opposing force is due to mass of the element, and the second one is due to this k, spring constant Fk, and the next one is Fb that is opposing force due to a dashpot. Now what is Newton's law? Applied forces is equal to opposing forces Fm plus Fk plus Fb. And anyhow, we know the individual force equations for a mass, spring constant, and dashpot. Let me write. For mass, it is m into d square x by dt square plus spring constant k into x plus dashpot, that is b into dx by dt. Now we need the Laplace transform of output, that is x of s, the input Laplace transform of input, that is f of s. This is what we need. Now apply the Laplace transform equations for this equation 1, what is that we will get? F of s is equal to m into s square into x of s plus k into x of s plus bs into x of s. So see, all these values already we have seen in previous class. Now f of s is equal to, what is that we will get? By taking x of s common, we will get ms square plus bs plus k. So x of s by f of s becomes 1 by ms square plus bs plus k. Now if I make s square term is 1, that becomes, if I take m common, it becomes s square plus b by m into s plus k by m. So finally x of s by f of s becomes 1 by m by s square plus b by m into s plus k by m. With the help of this previous equation, that is x of s by f of s is equal to 1 by m by s square plus b by m into s plus k by m. And if you look at this equation for mechanical system, the similar equation we got for electrical system also, that is for a second order system, that is where we have taken RLC series circuit. That RLC series circuit is, what is that we got? V naught of s by Vi of s is equal to 1 by LC by s square plus R by L into s plus 1 by LC. The similar equation we have for electrical system. Since there is some relation between mechanical system and electrical system, that relation we can call it as analogy between the electrical system and mechanical system. Okay, that is a separate topic that we will see in some other class. Now like this we can have the transfer function for various types of mechanical systems. Now if you look at the topics what we have discussed so far, from the mechanical system we have seen finding the transfer function of the mechanical system, and we started with defining the transfer function for various systems. Out of that we have find transfer function for a open loop system, a closed loop system, and also the electrical system, and finally this mechanical system. Thank you.